The next section of the review that we're going to look at is polynomials. This covers problems 13 through 20. So the first thing we want to look at is simplifying polynomials involving addition and subtraction. So remember that in order to do this, we're going to clear the parentheses, distribute the negative if needed, and then combine like terms. So for example A, we have 9n cubed plus 5nm squared plus nm minus 11. We want to distribute the negative to the second set, so we're going to become plus 2n cubed plus nm minus 15. From there we can combine like terms, and remember that when we combine like terms we add the coefficients, we keep the variable, and we keep the exponents. So we should get 11n cubed 5nm squared has nothing to combine with, so we're just going to bring it down. Nm plus nm is 2nm. And negative 11 and negative 15 combine to give me negative 26. And we're done at that stage. For problem B, as this is an addition problem, none of our parentheses have any real special meaning in terms of computations. So to clear the parentheses, we just rewrite without parentheses. So we'll go ahead and bring down everything except our parentheses. And then combine. So we have negative 9u cubed and u cubed combined to give us negative 8u cubed. Negative 5uv squared has nothing to combine with, so we'll bring it down. Vu and negative 13vu gives us negative 12vu, and negative 11 plus 15 gives us plus 4. The other one we want to look at is multiplying. Remember that with multiplying we are going to FOIL, and it's important to note that we are going to FOIL on all of these. So for instance, example A, if we FOIL, we're going to multiply our firsts together. 11y times 15y is 165 y squared. Y times y is y squared. Our outsides, we get 11y times 3 is 33y. Insides, we get negative 9 times 15y is negative 135y. And negative 9 times positive 3 is negative 27. We can then combine our like terms. We get 165 y squared minus 102 y minus 27. Okay, for example B, we do not distribute the square. Remember that when we square a binomial, we want to start by rewriting in expanded form. This is 6m minus 2 times 6m minus 2. So now I have it set up so that we can go ahead and FOIL. So we get 6m times 6m is 36m squared. Outsides, we get 6m times negative 2 is minus 12m. Insides, we get negative 2 times 6m is negative 12m. And last, we get negative 2 times negative 2 is plus 4. We combine our like terms, and we get 36m squared minus 24m plus 4. All right, example C. We have difference of squares. If you recognize that, then that's great. If not, we can go ahead and again FOIL as well. So we get first 3x times 3x is 9x squared. Outsides, we get plus 21x. Insides, we get minus 21x. And lasts, we get minus 49. Sorry, we should have y's on all of these. We get 49y squared. When we combine our like terms, our 21xy's cancel, and we are left with 9x squared minus 49y squared. Last one, just to emphasize this idea of squaring a binomial. Again, we're going to go ahead and write this as 5x plus 4 times 5x plus 4. When we FOIL, we get 25x squared for our firsts plus 20x for our outsides. Insides, we get plus 20x. And lasts, we get plus 16. When we combine like terms, note these do not cancel because they have same signs. We add them and we get 40x. And so our final answer is 25x squared plus 40x plus 16. All right, that takes care of multiplication. The next thing we're going to look at is our rules of exponents. Some rules of exponents that we have. We have our product rule, which says when multiplying things with the same base, we add the exponents. We have the quotient rule. When dividing, we want to subtract the exponents. And the power rule. When raising an exponent to another exponent, multiply the exponents. All right, let's see what we got here. So for the number part, we're going to just cube the number. And if our number happens to be a fraction, remember that we cube the top and the bottom. So if I apply my cube to my number, I get negative 27 over 7 cubed is 343. If we cube x, we get x cubed. If we cube y squared, we get y to the 2 times 3, or 6. And if we cube z to the 4th, we get z to the 4 times 3, or 12. All right, we're done with that one. Let's look at example B. Example B, to start off with, this 2 on the outside, just kind of set it off to the side. If you want to do anything with it, you can make it 2 over 1 so that we can go ahead and multiply our fractions in our next step. From there, we're going to go ahead and square everything. We're using our power rule. We get the square of negative 6 is 36 over 11 squared is 121. This will be positive because remember, when you square a number, it's always going to be positive. All right, if we apply it to the other ones, we get a cubed squared is a to the 6th. B squared is b squared. And c to the 4th squared is c to the 8th. Let's go ahead and bring in the 2 now. If we multiply by 2 over 1, we get 72 over 121. A to the 6th, b squared, c to the 8th. All right, that's example B, and that's our power rule. Let's come over and look at a little bit of our quotient rule. So for C, we're going to go ahead and subtract the exponents. Remember that when we talk division, we're essentially canceling out. And so for instance, 4 and 6, if we start with our number, 4 and 6 are both divisible by 2. So we get negative 2 over 3. For my x's, if I have 7 on top and 2 on bottom, I can cancel 2, and we are left with x to the 5th on top, or 7 minus 2. Y has nothing to cancel with, so we're going to go ahead and just leave it on top. And now for our z's, we have z cubed over z to the 5th. If I have 3 z's on top and 5 z's on bottom, I can cancel out 3 of them, and I am left with z squared on the bottom, or 5 minus 3. Okay, let's look at example D. Example D, starting off with our numbers. Negative 10 and 25 are both divisible by 5. We get negative 10 divided by 5 is negative 2. 25 divided by 5 is 5. We can subtract the exponents for our x's. 5 minus 2 is 3. We're going to put it on top. Y stays the same. We can move our 2 down to the bottom, and we get z to the 8 minus 2 is z to the 6. All right, so there are some rule of exponent problems. Next thing we're going to look at is some word problems, though these are not technically word problems. This is going to be basically an application of evaluating. So the first thing we're going to do is we want to plug in the values for their variables and simplify using order of operations. So for example 16, we have the polynomial s equals 2lw plus 2lh plus 2wh describes the surface area of a box. We want to find the surface area of a box with a length of 8 inches, a width of 6.5 inches, and a height of 4 inches by evaluating the polynomial. So what that means is we're just going to go ahead and plug in what we know. I'm going to go ahead and write out my formula again. All right, so we have L is 8. So wherever we see an L, we're going to plug in 8. We have W equals 6.5. Wherever we see 6.5, or wherever we see W, we're going to plug in 6.5. And we have H is 4. Wherever we see H, we're going to plug in 4. All right, let's go ahead and simplify this now. And so I'm going to use my calculator just to make it a little bit easier on ourselves. If we multiply 2 times 8 times 6.5, I get 104. 2 times 8 times 4, I get 64. And 2 times 6.5 times 4, I get 52. If we go ahead and add this up now, we get S equals 220. As this is a surface area, remember that area has square units, so this is going to be inches squared. Okay, for problem 17, we have the height in feet of a baseball after t seconds can be modeled by the equation h equals negative 16t squared plus 100t plus 4. We want to find h when t is 4 seconds. So notice this is not one of those ones that we have to solve for t. We're being given the t value. So be very careful on this problem. Most students miss it for that reason. All we want to do is plug in 4 for t and simplify. So when we do that, we get negative 16 times 4 squared plus 100 times 4 plus 4. If we go ahead and simplify this, this is negative 16 times 16. We get negative 16 times 16 is negative 256. 100 times 4 is 400. Plus 4. And so now if we go ahead and simplify this, we get h equals 148, and we are told height is feet. All right, so that takes care of our application problems. Let's see what else we got. Next thing we have is we do have some problems involving factoring. So in general, we've talked a lot about different ways to factor. So we'll talk about what we're going to do on each one of these. The first thing we want to do is factor out the GCF if possible, and then finish factoring. So each one of these has kind of a different approach to it. If we look at A, we have 4 terms. And if you recall, when we have 4 terms, we want to factor by grouping. So for the first set, I can factor out an x. And if we factor out an x, we are left with 2x plus 3. Remember, we're going to divide each term by the greatest common factor. Plus the second set. 4 and 6 are both divisible by 2, so I'm going to factor that out. And both of these terms have a y, so we can factor that out as well. If we divide each term by 2y, we are left with 2x plus 3. Now we want to look at these as our terms in quotation mark. And what do they have in common? They have 2x plus 3. So I can factor out a 2x plus 3. Just like before, I'm going to put that in front of a set of parentheses. Inside, I'm going to put my x. If we get rid of the 2x plus 3 in the first term, all we're left with is x. In the second term, if I get rid of 2x plus 3, all I'm left with is 2y. And we're done. All right, B. The first thing we want to do is we want to factor out the greatest common factor. So all of our numbers are divisible by 5. All of our terms have an a. So now if we divide each term by 5a, I am left with b squared minus 4b minus 21. All right, we want to go ahead and factor this leftover thing, the b squared minus 4b minus 21. We get b squared, that is going to be b and b. Things that multiply to 21, we have 7 and 3. Remember that when we have multiplying to a negative 21, this tells me different signs. And my larger one is negative. And finally, to finish off our answer, we want to bring down the 5a. All right, so we are done with that one. Let's keep going. If we look at C, C only has 2 terms. Does it have a greatest common factor? The answer is no. So when we talk 2 terms, what's the only other option that we have? Well, it must be difference of squares. And in fact it is. So 4x squared, this breaks down to 2x and 2x. 49y squared breaks down to 7y and 7y. And we have different signs. Right, we're done with example C. Let's go to example D. Example D, again, the first thing I want to do is check for greatest common factor. We do have a greatest common factor here. I can factor out a 2, and all of my terms have an x in common. Okay, so now we have, if we divide each term by 2x, we are left with x squared minus 7x plus 12. I'm going to bring down my 2x, and then I'm going to factor this leftover thing. So x squared, that's going to be x and x. Things that multiply to 12 and combine to 7, we have 3 and 4. And this time, remember that if you are multiplying to a positive 12, that tells you same signs, and both are negative. All right, that takes care of some basic factoring. The next thing we're going to look at is solving quadratics using factoring. No quadratic formula on this one. So remember that in order to do this, we're going to move all terms to one side. We want to factor, and then we're going to set each factor equal to 0 and solve. So for example A, the first thing I need to do is I need to get all terms to one side. So I'm going to subtract 6 from both sides. We get m squared minus m minus 6 equals 0. If we factor this now, we get m and m. Things that multiply to 6 and combine to 1 is going to be 3 and 2. Remember that we do have different signs. My larger one will be negative. So we get m minus 3 and m plus 2. So if we go ahead and set each one of these equal to 0, we can now solve the little linear equations. We can add 3 on the first one, and we can subtract 2 on the second one. So our solutions are m equals 3 or m equals negative 2. Not sure how they're going to want the notation on the final exam this semester, but if you want, you can also write this with squiggly brackets. All right, B. If we go ahead and factor this, it's already set equal to 0. We get 2x and x. What multiplies to 4? Well, 2 and 2 would not work because we cannot put a 2 in with the 2x. We want to go with 1 and 4. 4 cannot go with 2x, so I'm going to put the 4 in the second set and 1 in the first set. We do still have same signs, and both are negative. So now if we go ahead and set each one of these factors equal to 0, I can add 1, in the first one, and then divide by 2. We get x equals 1/2. Or, in my second factor, I get x equals 4. Okay, last one. This is already set equal to 0, so we want to go ahead and factor it. 5x squared, things that multiply to 5x squared is 5x and x. 14, I consider it to be a large number, so I'm going to put my 3 to multiply with my 5, so that means in the second set, and 1 in the first set. We are multiplying to a -3, tells me different signs. And I want my larger quantity to be negative, so I want my 15 to be negative. That means the 3 will have to be negative, and my 1 will have to be positive. Okay, we set each factor equal to 0. And we solve. So in the first one, we're going to subtract 1 from both sides. And divide by 5. We get x equals -1/5. In the second one, I can add 3 to both sides, and we get x equals 3. All right, that takes care of solving quadratic equations using factoring. The last problem that we're going to look at in this presentation is some word problems. Now these ones are word problems. We are going to have to translate to a model, and we are going to have to solve. So for this, we do want to use the fact that A, the formula for the area is A equals length times width. So for example A, we have the length of a building is twice its width. If the floor area is 288 square feet, what are the length and width? So let's start off with this first statement. We have L is equal to twice the width. So L equals 2W. We can now go ahead and plug that into our formula. We get our formula is A equals length times width. We get 288 for our area. We said L was 2W times W. So we get 288 equals 2W squared. I'm going to go ahead and use factoring in order to solve this. So in order to do that, we want to have it set equal to 0. We get 0 equals 2W squared minus 288. I can factor out a 2 to make it a little bit easier on myself. If we factor out a 2, we get W squared minus 144. This is a difference of squares. So we get W squared is W and W. 144 is 12 and 12. And my signs are opposites. So if we go ahead and set each factor that has a variable in it equal to 0, first one I can add 12 to both sides. We get W equals 12 feet. The second one, we subtract 12 from both sides. We get W equals -12. We are going to discard this because we are talking about the length of a building, and the width of a building cannot be a negative number. And so my width is 12 feet. Now we still have to find the length. So my length is going to be 2 times my width. or 24 feet. All right, the last one. We have the length of a rectangular area is 7 meters more than its width. If the area is 78, we want to find the length and width of the rectangle. Okay, so let's see here. Let's start off with our first statement. The length is 7 meters more than the width. So if we set that up, we get W plus 7. All right, if we plug into our area formula, we get A equals 78. L is W plus 7 times W. I can distribute to clear my parentheses, and we get 78 equals W squared plus 7W. I'm going to subtract 78 from both sides. We get 0 equals W squared plus 7W minus 78. All right, we want to go ahead and factor this. Now, personally right now, for me, it is almost 4 o'clock in the morning, so I'm going to go ahead and do this the longhand way. I want to figure out things that multiply to 78. So we have 1 and 78, 2 and 39, 3 and 26. 4 does not go into 78. We have 6 and 13. Yes, 6 and 13. All right, these are the numbers that I want to work with, the 6 and 13. So we get 0 equals W and W. We have 13 and 6. We do have different signs. My larger quantity will be positive. So we get W plus 13 and W minus 6. All right, if we set each one of those equal to 0, we get W equals negative 13, which we will discard because, again, our width cannot be a negative number. And we get W equals 6. So our width is 6 meters. And our length, we're going to plug our 6 back into our little equation for our L. We get L equals 13 meters. Okay, that takes care of our look at polynomials. The next thing that we're going to look at is rational expressions and equations.